Okay, so we're going to start our lesson on 3-1, which is all about the graphing of the trigonometric functions, and we're going to start with f of x equals sine x. So graph the function f of x equals sine x with x as the independent variable. So what we're saying is our x values are going to be our angles from the unit circle, and they are going to be our special angles in radians. Okay, so they're telling you here that sine of 0 is 0, sine of pi over 6 is 1/2, sine of pi over 2 was 1. Okay, any of our pi over 6, regardless of the other part of the numerator, we know from our experience is going to be 1/2. Okay, so we go ahead and we can put in 1/2. All right, now what we have to figure out is, well, which quadrant is it in, and is sine positive or negative? So first quadrant, positive. Second quadrant, also positive. Third quadrant, negative. Fourth quadrant, negative. All right, so then we look, well, what is sine of pi? Okay, well, pi, the coordinates for pi were on our circle, we used -2, 0. So that means y over r, 0 over 2, is going to be 0. Okay. At 2 pi, right, we were at 2, 0. So again, pi will be, sine of pi, 2 pi, will be 0. Okay. Then at pi over 2, we were at 1. So at 3 pi over 2, we'd get a 1 value, but because we went down the y-axis, we would be at -1. Then we can see with our negative radians over here, we're just going the opposite direction. So we're going to read our table up and fill in this table down. So that's going to be negative pi over 6 would be -1/2. Negative pi over 2 would be -1. Negative 5 pi over 6 would be the same as 7 pi over 6, which was -1/2. Negative pi would be 0. And we just keep going. So 1/2, 1, 1/2, and finally 0. Okay, so that's how you fill in your table. Okay, note from our experience with the unit circle, you'll notice that pi over 4 and pi over 3 and their various angles are not listed, and that's because they're not friendly. Right? If we put pi over 4 here, I'm going to get square root of 2 over 2. Not exactly graphing friendly. Okay? All right, so let's plot these points on our graph. So we had 0, 0. Pi over 6 was 1/2. Pi over 2 was 1. 5 pi over 6 was 1/2. Pi was 0. Okay, the next thing on our table was 7 pi over 6. I don't have 7 pi listed, but it tells me right here I'm counting by pi over 6. So 1, 2, 3, 4, 5, 6. Here would be 7 pi over 6. Okay, and that was -1/2. Okay, 3 pi over 2 was -1. Okay, then 11 pi over 6. Well, 7, 8, 9, 10, 11. Would be -1/2, and then back to 0. Okay, kind of going the other direction. Negative pi over 6 would be here. So we get -1/2. Negative pi over 2 is -1. Okay, and then we're coming back around. So let's see. That was negative pi over 6. So the next one would be -5 pi. So 1, 2, 3, 4, 5. And we're back to -1/2. Negative pi is 0. It's -7 pi over 6 is 1/2. -3 pi is 1. And then, let's see, 7, 8, 9, 10, 11. Would be 1/2, and -2, 0. Okay, so this is our sine graph, and we curve it around. Okay, it's like a wave. Think ocean. Okay, any of you have ever seen sound waves, right? Okay, all right. So now let's answer some questions. Okay, so set your calculator to radians mode. Okay, so document 7.2, and we change from degrees to radians, and we're going to make that our default. Okay. All right, and then it says enter y1 with our this particular calculator. We're actually going to have f of 1 of x equals sine x. Okay, so trig sine and then x and enter. Okay, and then it says set the window for the following. Okay, to set our window, we do menu number 4, then 1. Okay, and here they said let that be negative 2 pi. Okay, and then our next one will be 2 pi. Whoops. Okay, I hit too many enters. Let me go back. Menu 4, 1. All right, so my first two now, you'll notice they're in decimal version, but that's okay. We're going to change our x scale. We're going to enter a value, and it will be pi over 2. Okay, and then y min, y max, negative 2 and 2. Okay, and then the y scale should be 1, so we're just going to change that to 1. Okay, and then we're going to tell the calculator, okay, that's good. So hopefully yours now looks like that, and that's pretty much what the graph we made together on the front sheet of paper looked like, and that's exactly the scale we set up there was the same as the one on our paper. Okay, so now we're looking at, well, we just compared. So now they want us to change our window to be negative 4 pi and 4 pi. Okay, so we go back, menu 4, 1, and we're just going to change that to negative 4 pi. And then 4 pi. Okay, and that's all they asked us to change, so we'll say okay. And now you can see that where there were two or a single period here, now there are twice as many things. So what does the graph look like when x is greater than 2 pi? It's just more of the same. Okay, so since when we start at 0, the graph completes one cycle at 2 pi. Okay, so that's, we're saying from here at the origin, comes around, and then here's 2 pi, that's one cycle. So since it completes one cycle at that point, we say our P, or our period, is 2 pi. Okay, so now we're going to reset our window back. Whoops, hit the wrong button. Menu 4, 1. And change that back to, oops, not 2, negative 2. Two pi. Okay. All right, so now we're back to the original graph. All right, answer the following questions for x in this interval from negative 2 pi to 2 pi. So the maximum value of f of x is what? Well, that's f of x is here on our y-axis, and so the maximum value is 1. Okay, now if you need to, because it's not as easy to look from the graph, go back a page and see, well, where did this happen? Okay, so where was f of x1. Okay, that happened at pi over 2, and then again at negative 3 pi over 2. Okay, what is the minimum value? Well, you can see that's this minimum value here is negative 1, and that happens at 3 pi over 2 and negative pi over 2. The domain, well, they told us right here. It's going to be the interval, there it is, negative 2 pi and 2 pi. So that's our domain. That's all the possibilities for x, because that's the only part of the graph we're looking at. Okay, and in that time, what is our minimum y value? Negative 1. What was our maximum? Positive 1. Okay, the x-intercepts. Where is y0, or f of x equal to 0? Okay, so go back to your table, take a look. 0, pi, 2 pi, negative pi, and negative 2 pi. Okay. So that was at 0, 0, pi 0, 2 pi 0, negative pi 0, and negative 2 pi 0. The y-intercepts, just the 1, crosses the y-axis at 0, 0. And then is this an even or an odd function? Okay, so just a quick reminder, if it's an even function, then we would see axis symmetry. Okay, if I were to fold here on the y-axis and it flips over and it's exactly a mirror image, that would be even. That didn't happen here. Odd is a little bit harder to see sometimes, but that's origin symmetry. In other words, what was up here is now down here. What's over here is down here. Okay, so we have origin symmetry, which makes this an odd function. Okay, the way you can check that is, remember, an odd function, f of negative x is equal to negative f of x. Okay, all right. I'm going to go ahead and stop this one here, and we'll pick up with another video on cosine.